Okay, hello everyone, and welcome to trimester 3. Guys, Intermediate Algebra 2, I'm Mike McCartan. Guys, I just want to show you quick kind of the agenda. And when you come into class, I'll go through this again, so you kind of get a feel for how we do things in this room. Okay? Guys, I like to have 2 Zoom meetings each class period. Okay, they won't be long, but I like to have 2 of them. All right? One at the beginning and one right in the middle of class, like at the 50-minute mark. Okay, every day there are 2 folders you have to go into. There's a green folder. Inside there's a video you watch. All right, and there's 2 puzzle piece assignments that you need to complete. And then there's an orange folder. Again, there's a video to watch, and there's 2 puzzle piece assignments to do in the orange folder. Okay, we'll go over this more when you get into class. As here today, the title of the lesson is Key Features of Quadratic Functions. Okay, we're going to keep looking at quadratics. They're very important in Algebra 2. By the way, you need to know this right here, the title of today's lesson for the notes assignment, which is one of the puzzle piece assignments in the green folder. Okay, today's objective, of course, to identify the key features of a quadratic function. It looks like this, you guys. It's shaped like a U. Looks like this. All right, again, the essential question, and you need to know this for the notes assignment. It's worth 5 points. What are the key features of a quadratic function? Okay. Guys, there's not a lot of calculating today. All right, we're just going to learn some vocabulary and some concepts about the key features. Now, if you guys remember, a quadratic function has a degree of 2. In other words, it has this x squared in there. If it doesn't have an x squared, it's not a quadratic. All right, but it can't have an x to the 3rd or x to the 4th or x to the 5th or something like that. It cannot have that. The highest degree can be 2, but it has to have an x squared, or else it won't be shaped like a U. Okay? And again, when we graph a quadratic, it's symmetrical. All right? And it's shaped like a U, or it could be upside down, like an upside down U. All right, guys, the quadratic parent function. This is one of the vocabulary words for today. It's right here. F of x equals x squared. That's the parent function, or y equals x squared. All right, it's graphed just like this. Again, shaped like a U. The vertex is at the origin. All right, the graph of the function, the graph of a quadratic, the curve is called a parabola. It's a parabolic curve. Right? The vertex is the minimum or the maximum value of the function if it's flipped upside down. Right? The axis of symmetry is a vertical line straight up and down that goes through the vertex. In this case, it's the y-axis. So the axis of symmetry for the parent function is x equals 0. And again, for the parent function, the vertex is at the origin, 0, 0. This parabola opens upward. Okay. Guys, the axis of symmetry intersects the vertex and divides the parabola in half, into 2 equal halves like a mirror. Okay? Now, how does the value of a affect the graph of the quadratic parent function? This a that's in the front here, in front of the x squared. If we change the a, how does that affect the graph? All right, now we're going to look at Desmos in the second video, which is in the orange folder, and play with a little bit. But I'm going to tell you right now the 3 things that a does. Guys, when a is less than 0, like -2 or something like that, the graph is flipped upside down. All right, that's when it's an upside down U. Guys, when a is less than 1, like a is a half, or it might be -1/2, all right, then the graph is wider. It goes up slower. It's a wider U, all right? When A is less than 1, like A is 0.5 or 0.3 or a half or a third or something like that. Now, when A is greater than 1, like A is 2 or 3 or 4 or 5, or even if it's negative, -3 or -7 or -10, or what does that do? It makes the graph narrower. You know, it makes it kind of skinny because it goes up faster or down faster if it's upside down, right? But it goes up faster, right? For the same value of x, y is bigger or bigger negative. Also, guys, a quadratic, it has an interval of increase and an interval of decrease. And it changes direction at the vertex. So if the graph is upside down, like the one here on the left, the increasing interval is on the left side. On the left side right here. And the right side is the decreasing interval, where it comes down like this. Again, the interval itself you get from the x-axis. But whether or not it's increasing or decreasing, you refer to the y-axis. The output of the function itself is the y-coordinate. And here it's coming down. As x gets bigger, the function is coming down. Now over here on this one, where the u is right side up, on the left side, it's where it's decreasing. As x gets bigger, y is getting smaller here. But at the vertex, it switches. So again, as x gets bigger, now y is also getting bigger. So it increases on the right side, all right? All right, guys, so again, if the function is 4x squared, over what interval is it increasing? You might get a table, and you have to determine this. All right, look at the x coordinates, and just as they get bigger, what happens to the y coordinates, or the f of x? Well, as you can see, it starts at 16, then goes to 4, then goes to 0. It is decreasing here where x is negative. It's decreasing where x is negative. But at 0, it flips around. Look at the y coordinates. It's increasing from 0 to 4 to 16. It starts to increasing, okay? So this particular function, just like the parent function, it's decreasing over the interval where x is less than 0 and increasing over the interval where x is greater than 0. If it was flipped upside down, it would be the opposite. All right, last thing, guys, rate of change. We talked about this when we talked about linear. The rate of change is the slope. And remember, in a linear function, it's a straight line, so it has a constant rate of change. Guys, but a quadratic function is different. It has a constantly changing rate of change. All right, the rate of change is changing. But in a quadratic, it is changing at a constant rate. All right, it's a difficult concept, guys. If you go into calculus, you will learn that the second derivative is 0 of a quadratic. All right, whereas as a linear function, the first derivative is 0. Okay? Now, I want you to take a look at these two functions. This one is 2x squared, and this one is just x squared. All right, and look at just the positive side here. Any interval between any two x points, if we measure the slope of the lines of the intersection of these curves, the slope would be twice as steep for the red function than the blue one. All right? The greater the value of A, the greater the average rate of change over any positive interval. And the ratio of those rates of change is the same as the ratio of the A values. Okay? And guys, I just want you to explain that to you. I'm not going to make you calculate too much of that. I just want you to understand that. All right? Rate of change is important. All right, guys, right now, go ahead and fill out today's notes assignment and complete the summary assessment, which is in the green folder. All right, then get ready for the next Zoom meeting. All right, these are the vocabulary words. You're going to need those for the notes assignment. Quadratic parent function, parabola, vertex, and axis of symmetry. All right, that's it. Thanks, guys, for listening.